Hello everyone. Today we will learn about the practical separation of mixtures of amino acids by thin layer chromatography technique. For that, let us first learn what do we mean by chromatography. It is a technique which is used to separate, identify as well as analyze the complex mixtures of the substances. This process involves passing a mixture through a stationary phase which then interacts very differently with each of the components of the mixture. As the mixture moves through the stationary phase, the components get separated into very distinct bands which can then be analyzed. Now let us see what do we exactly mean by thin layer chromatography. It is a type of chromatography in which very thin layer of stationary phase is used to separate the components of the mixture, and hence it is given the name thin layer chromatography. Why it is named thin layer is very much evident from the type of stationary phase that we use here, which is a very few micrometers thick. Now let us know about the retention factor or the RF value. The behavior of an individual compound in TLC is characterized by a quantity which is known as RF or the retention factor and is expressed as a decimal fraction. The RF is calculated by dividing the distance of the compound travelled from the original position by the distance of the solvent travelled from the original position. Chromatography can be analytical or preparative, but the basis of all forms of chromatography is the distribution or partition coefficient, which describes the way in which a compound or the analyte distributes between two immiscible phases. For two such phases, A and B, the value for this coefficient is a constant at a given temperature and is given by the expression P, which is the partition coefficient, equals to concentration of solute in phase A divided by the concentration of solute in phase B. Here in this experiment, we will be using four types of amino acids, which are glycine, leucine, tryptophan and proline. Along with this, a mixture of the unknown amino acids will also be used, and after the completion of this experiment, we will be able to know which of the amino acids were present in those given mixture. To start with our experiment, we will first prepare our spraying reagent, which is the ninhydrin solution. For that, we need to weigh 0.075 grams of ninhydrin and mix it into 25 ml of 95% alcohol. Now, we need to prepare the standard amino acid solution. For that, we will dissolve 15 mg of each of the amino acids separately in each vials in 1 ml of distilled water to make the concentration of 15 mg per ml for each of the 4 standard amino acids that we have used. To prepare the mobile phase, we are adding here, as you can see, 1 ml of water, 2 ml of acetic acid and 8 ml of butanol to the TLC chamber. This will work as the mobile phase. Now, to ensure that the chamber is airtight completely, we will apply Vaseline on to the top of the chamber and then put the lid over it and press it gently so that no air bubbles remain. After that, as you can see, the TLC plate, which is pre-coated with the silica gel, is taken and the baseline is drawn from 1 cm from the bottom. Now here the positions where the amino acids will be put are being marked. Name it as the initials of the amino acid so that it becomes easier for us to understand after the experiment that which amino acids was put. Here, as you can see, we have taken the capillary tube for the amino acids to be put into the TLC plate. Here, as you can see, the standard amino acid solution along with the mixture has been kept with the capillary tubes so that some of the solution rises up the capillary tube by capillary action. Now, as you can see, one by one, the capillary tube from each of the amino acid is taken and put into the TLC plate. Make sure that you close the other side of the capillary tube while you are bringing out the tube from the vial, and then when you put it on the TLC plate, release the other side so that the amino acid that has been absorbed in the capillary tube drops down into the TLC plate and makes a small diametric circle. We have to repeat this step for each of the amino acids that we have labeled in the TLC plate. After completion, we put the TLC plate into the TLC chamber very carefully using the forceps. Make sure that the baseline does not completely immerse into the mobile phase. After that, close the lid of the tank and allow the mobile phase to ascend along the plate until it touches the 3/4 of the distance from the baseline. In the video, we can see very clearly how the mobile phase is rising slowly into the TLC plate. After some time, we will observe that the mobile phase will travel 3/4 of the distance into the plate. That is the time when we have to take it out and then let it dry for 5 to 10 minutes in the room temperature. After that, spray the freshly prepared ninhydrin reagent onto the dried plate and place the plate in the hot air oven at 100 to 105 degrees centigrade for about 2 to 5 minutes till the chromatogram dries. Appearance of colored spots will indicate the presence of the amino acid in that region. Here in the video, you can see the developed color spots. Here is the photo which shows the different spots which has been occupied by different amino acids. After we have completed the experiment, we measure the distance of the spot from the baseline and note the distance which has been traveled by the mobile phase also. After that, we find the RF values by dividing the distance traveled by solute to the distance traveled by the solvent. We can use these RF values to know which amino acids were present in the mixture. That comes with the completion of this video. I hope this video was informative. Thank you.